All right. Was anyone just over at the theater? No. Oh, lucky you that you didn't have to hear me talk twice in a row. Sorry, we're getting a little bit of a late start. I had to run over from the other side there. How's everyone doing today? Good? Yeah? All right, sweet. How many people here are familiar with Meraki and what that actually means? All right, that'll be very helpful for this discussion. Thank goodness. Welcome, welcome. My name is Matt DiNapoli. I am a developer advocate for Cisco DevNet, and I focus specifically on Meraki and everything having to do with APIs and integration and all that fun stuff. And what we are here to talk about today is a little bit of integration that our co-creations team had done in their booths over there. And it's called Meraki Beat. What it does is it takes three API sets, mashes them together, and allows them to take a look at all of the resulting information into a dashboard. But this wouldn't be a DevNet talk without talking about the APIs in specificity. So we'll spend some time on those APIs. But before we get into that, I can never find my cursor when I do these presentations. There we go. So we're going to talk about why we actually built this sample, I should say. And actually, it's really good code. I have to say our code creations team is really good. This is something you could take as a base project. All of the code is available on our code exchange. And I'll talk about that at the end of the talk. But this is a pretty good piece of code that allows you to kickstart your application if you wanted to do that. So we'll talk about that. I will give a quick introduction about Meraki's new security cameras. This is not going to be, it'll be a little bit of an advertisement for the security cameras, but it kind of sells themselves. Mainly be talking about the features and functions I think you will find interesting, and then how you get the data out of it. So we'll do that. We'll look at the camera and dashboard APIs. We'll talk about the location APIs, and then I'll actually run that sample on the source application. So, the thing that we wanted to solve was the distribution of people in areas. So dealing with long lines at ticketing, being able to tell people, hey, something over here is open and you can get the same kind of service. Maybe there's a long coffee line and you could hit up the other barista down the street or something like that. Those kinds of things are the things we would like to solve. And to do that, we need to actually generate some data around it and be able to count the people that are in line or be able to count devices that are in a space. And so that's why we kind of took on this particular sample, and because it's something that affects pretty much all modes of human interaction, transportation, retail, industry, all that fun stuff. And so what we want to do is to be able to auto-detect people either through visual detection through cameras or through Wi-Fi device detection. Define zones specific for those detection areas so that we know we're not talking about, so we're talking about this classroom here and we can say, oh, there's, let's see, maybe 50 people in here versus 30 over in classroom 1, and being able to take the data and delineate it between the two spaces, capture that real time, or as real time as we can, and doing some analysis and alerting based on that. Hey, things are getting super crowded in this area. Why don't we let off some steam and open up a valve to another place? That kind of stuff. This will enhance our queue management. So lines can be longer at specific times of day, days of the week, times of year. If the holidays are coming around, maybe you need to deal with that. And this will give us real-time and historical queue length information or crowd information if we want to. And so not only can we make decisions in real time, we can go back in history and see, all right, for this next period, I see that for Cisco Live events in Barcelona, the lines at the airport are long. Okay. Now we know that when Cisco Live comes back to Barcelona, we need to have more staff on hand, and we can see that through the analysis of our tracking data through our cameras or potentially our Wi-Fi devices. We can do things, and I saw this one was really cool. For those of you who aren't familiar, DevNet has its own conference in California in the United States called DevNet Create. And as part of that, we run a program called Camp Create, And we have people work on use cases that we kind of propose to them, or they propose, and one of them was this automated school attendance. And I was talking to some teacher friends of mine recently, and it was really interesting. They really have a hard time, they're college professors, in doing all their work and then making sure that the kids are actually coming to class and staying, especially in situations where it's a university and there's large classrooms. So they were talking about different scenarios about how they wanted to track their students and be able to engage them via digital means. And I had actually mentioned a scenario where we could track their Wi-Fi device. They could register it with some back-end service. Doesn't have to be anything tied to a specific technology, but they could register it with a back-end service. And whenever Meraki would see that device enter that space, they could tag them as having attended. Now, we could take that whole design a little bit further with cameras and say, now your face is the device, and we can maybe do that. We weren't that far along in the technology to be, or we may or may not be that far in the technology to do something like that, but conceptually you could think about those kinds of things. But if their device is in the space, you could say, hey, that person was here, and to take that example even further, what they did was, when they walked in the room, it added them to a WebEx Teams room for that day. Or it could be some other messaging application, but it added them to that WebEx Teams room for that day. Now they could send them notes, they could send them the assignment for the day, the student could turn in their assignment through that process, and so it made that whole interaction a lot easier, quicker, and it allowed the professor to spend more time going through their lecture, teaching, doing the thing that they're supposed to do, and not administrative type tasks. So the whole idea is to take that administrative type task out of the place. We can also add in things like, one of our teammates lost his laptop yesterday. It was unfortunate, and we have no idea where it is. Had we actually tagged it, which now we maybe should, as part of our service here, we could have said, hey, it left the space. We could have known almost instantaneously that that was happening and potentially sent out security to go track that down. And if we had everything mapped, we could have actually identified exactly where it was. And if we had cameras in the space, we could have saw who did it. So those kinds of things can come into play as well. So it's sometimes security, sometimes some efficiencies, but being able to have that data right at hand is super helpful. So the MV-Sense camera, security camera, is the relatively new camera out of the Meraki family of products. It brings that Meraki magic. That's the actual first time I've used that term. But it is the Meraki magic, because everything is cloud managed, and the camera itself, all of its data stream, is visible in the Meraki cloud service. And I can actually show you guys. Why don't we take a look at that? I can actually show you guys the camera that's over at Workshop 3. And bear with me on some of the demos. I ran right from one talk to another, and so I don't have everything quite queued up the way I would like to. But if we go to our cameras section of our dashboard, and we go into that camera that's deployed, we can actually see a live feed of our workshop going on. And right now what's happening is that camera is actually collecting data on entrances. And so whenever any of these people came into that zone, it counted their face. And then the people that are in the back, it counts their faces. And then as people walk by, it counts their faces. I think we had something like 3,000 entrances yesterday going from just past this one camera. And so I expect it to be higher today, since we had more people today than we did yesterday. So this is the tie into that. I hope that wasn't me. And so that's what we're getting out of the Meraki camera. It does have solid state storage, and there is some processing that happens on board the camera as well. I've been told there's machine learning algorithms in place to make it smarter at being able to recognize one face from another. And not necessarily for identity purposes, just for saying that guy with a beard looks like that guy with a beard, and I'm going to only count them once, that kind of stuff. And so the video storage is on the camera, not in the cloud. And so, but there is support for cloud backup, so you can turn that on and off if you want to. I'm not going to worry about this architecture. We can generate motion heat maps. That's another item I wanted to show you guys. So if we go to analytics we'll build that up. Oh, there's all of our entrances. Yeah, we've had way more than yesterday, so that's awesome. And then we have heat maps, so we can see, obviously, wherever the desks are is going to be cold. And then we have all of our people hanging out there and all that stuff. And it does seemingly a pretty good job of identifying one person versus another. We can define zones. So just for fun purposes, so we can generate some data, I define the left side of the desks, the right side of the desks, and the back of the desks. And as we look at the APIs that are providing that data, you'll see those zones split out in the data stream as well. What else do we have? So how does this all play into our dashboards and APIs and all that fun stuff? So we have a set of, I'll come back to the health APIs because I don't like to talk about the cameras and then just leave you guys hanging on the camera APIs. So if you do have cameras, there are a set of analytics APIs that are available to us. And I'll blow this up. That allow us to then build out our applications like I was talking about, like this Meraki Beats, right? And so this particular call, and this is for that camera over there, is our analytics overview call. And everyone cool with REST APIs in here? Because I'm going to just gloss over that and not introduce it. Are we okay with that? Yes, some tepid nods. All right, we'll stick with it. So anyways, what I'm doing is I'm calling into the Meraki Cloud Service for my particular camera because I want to get that entrances, that analytics data out in some format that I can easily manage. In this instance, it's going to be JSON. In most REST API instances, it's JSON. And I want to build out my own dashboard across multiple organizations. That's the one that I came across that conversation a number of times yesterday. Specifically in Meraki and specifically with service providers who do managed Meraki deployments, it's kind of a pain in the earth to go from organization to organization in the Meraki dashboard and do that analysis or do that deployment or have a big overarching view of your whole customer set. So these APIs allow us to then mash those things together and tie in multiple organizations for things like visibility of APs being up and running, cameras being up and running, the data that's coming out of those cameras for each organization. So being able to tie multiple organizations together is one big use case that I've been hearing about that would be useful for these APIs. And so this one is the camera analytics overview. I haven't set a time frame. I just kind of want the whole time. It's going to make that API call. It's going to take a second here. And hopefully we'll get some data back in a second. All right, there we go. That took a little bit of time, but that's okay. I'm on a contained network, so that's why. But it tells me the average count for the camera from 213 to 313 today. We've had 3,037 entrances for that for the whole area, and then that's split out for each zone. And these, we'll take a look at the zones in a second. 1,144 for that particular zone for that time frame, and then the average per second for that area. The zones are set up in the dashboard. And under the settings. And so if I go to the zones area, I've defined those zones as right front here, this was left front, and then back row. And then they have their own IDs that I think we can pull them. Oh, return all configured analytics zones. And so we have right front, left front, back row, and it ties to those IDs that we saw in that data set coming back. Okay, so once you have the ID, then you can look up that specific zone's result set as well. Okay. So those are the analytics APIs, and I can do them for specific zones. I did them for the whole area just to give you an example, but I could do them per zone if I wanted to, for whatever reason. And actually, the demo that we have at the co-creations pod, the one with the mirror, if you haven't seen it yet, it's supposed to be a smart mirror. You talk to it and you say, how many people are in the Amazing Race, or how many people are in Workshop 2? And there are cameras deployed in those places that are actually counting people at that point in time. And it's using those APIs that I just showed you to tell you how many people are there at that time. Now, it's a little bit of a cheeky example, but it is leveraging those APIs to provide a real-world implementation. All right, now we can jump into the health APIs. So about 9 months ago, Meraki came out with these wireless health APIs. And the nice thing is that this is a big jump for Meraki into the notions of network monitoring. Historically, Meraki has been really, really good at provisioning and automated provisioning and getting our networks up and running across multiple sites with very little effort, especially around the APIs. But as far as network monitoring is concerned, you had to do things like email scraping or screen scraping of your dashboard and stuff that's kind of a giant pain in the butt. Well, with these wireless health APIs and some of the newer dashboard APIs, we're now able to do a lot more network monitoring. Now, for the purposes of this talk, we leverage the wireless health APIs, and the basic gist is they're going to give us traffic information over those particular access points. Now, the access point that I have running, the only machine on it is my laptop, so there's not a lot of traffic information coming from there. But it will tell me if there's latencies, if I'm running into any connection problems, if someone tried to connect and wasn't able to, those kinds of things. And we also have the ability to, I lost my train of thought, failed connections, wireless latency, and metrics around all of those things. I cannot remember what the third one that was I wanted to say. Client connections, connectivity, and latency. I guess that's it. And then failed connections. So those are new health APIs, and those are polling. So basically, you do have to make a REST call into them to make them to generate that data. We have, as part of DevNet, a whole bunch of learning labs. We actually have a wireless health learning lab, and I'm going to advertise that for fun. So if we go to learninglabs.cisco.com and you want to learn more about these APIs, we can do that. We don't have any learning labs yet for the cameras. Those will be coming very shortly. For those of you who are not familiar, we have something called the DevNet Sandbox, and we have in queue the plan to build out 20 Meraki specific pods that include an MV camera. So there'll be, as part of each of those networks, there'll be an access point. So you could play around with some of the location services. There'll be a MX65 if you want to try some of the security appliances, and then there'll be an MV camera to play with these APIs that we're talking about. Unfortunately, we do not have that yet. We do have the equipment, we just haven't put it in place. So keep an eye out for those coming soon. Fortunately, I'm going to change networks. So sit tight. I think it might be a little too far away. But if you are interested in learning about these APIs and how they're working for this particular service, the Learning Labs is the best place to start, and specifically the Getting Started with Meraki module, and I'll show you guys that real quick. And these are free to use, and they are designed as self-guided tutorials, so feel free to take advantage of those at OM, and you don't have to have Meraki infrastructure to make it work. You can use our sandbox environment or our always-on sandbox. But specifically, I wanted to call out, we have a wireless health API learning lab to walk you through how to run these API calls and what data comes back for them. All right. So our wireless health APIs. I showed you the video wall, people detection, people count analytics, interest zones. I don't really like using slides, as you can tell. I just put them in there to make everyone else happy, and they can use the decks later, but I actually like to show you guys what's going on. I showed you the camera analytics API. And now we've taken all those APIs, the location analytics, the camera, and the location API. I didn't talk about the location API. I did just talk about it over there, but as a quick overview, It is the ability for Meraki APs to track devices in a Wi-Fi space. There is a service that then collects that data, and our actual Meraki Beats instance will be sitting there collecting that data there. So that is those are the APIs coming from Meraki. We're using something called Elastic Beats. Elastic is the company, the organization that provided the Elk stack, so Elasticsearch, Logstash, and Kibana. We'll only be using the Elasticsearch piece and Kibana as part of our deployment. Elasticsearch is basically the database that we're going to be dumping our data into that's coming back from our calls. Kibana will be generating the front end and our visualizations for that. And then the Beats framework is the ability to ship that data from these 3 different sources through that Meraki Beat into Elasticsearch so we can pull and visualize it in Kibana. So build out those dashboards that are now useful to us on a day-to-day basis and allow us to see more into what's going on with our Meraki-based network. Okay. We did put together a point of sale simulator as well to show the ability to tie in what's going on with our network versus what's going in with our retail space. I didn't kick off that because this isn't a demo, it's a talk. I want to show you guys about the APIs, okay? So, this is the camera data pipeline. You might notice a little bit of a difference here between the health APIs, the camera APIs, and the scanning API. These are actually polling here. And so our Meraki Beat is actually making a call into the Meraki cloud service to get that data, whereas the scanning API, the receiver from the Meraki Beat is registering with the scanning API, and the scanning API is sending an HTTP post anytime there's location information coming from those access points. So that's one. It's a small part of this diagram, but it's a big distinction between how the APIs work within Meraki. We can, if you want to get a raw set of notifications from the Meraki cameras, we have the ability to set up something called MQTT. It's a pub sub bus that allows you to set up, it's basically a listener service waiting for information that it has specifically subscribed to, And whenever you head into the dashboard for the cameras, you can set up those through what are called the Sense section or the Sense APIs. And I have Sense enabled, and I can set up an MQTT broker to allow these MQTT topics to be sent to my service, to my MQTT listener that's sitting on one side. So as I get that raw data, I can process that out. Now I don't have anything processing it, but I can set up an MQTT broker. And again, I apologize for not being fully prepared for this since my previous talk started late. And so give me 2 seconds while I get the correct command in place here for the MQTT. There we go. So what I'm going to do is I'm going to subscribe to that MQTT service. And it is Meraki MV, the serial of that particular camera, and then all I'm asking is for raw detections. How many counts happen? If I wanted to, I could set this up per zone as well. So I'm going to kick that off. Oh, hold on 1 second. So that's why I was on that one network, but I'm so far away. All right, hopefully this all plays nicely and I can make this work. I need to get my IP address of my device so Meraki knows which one to talk to. All right, 56 should be the same as the configuration. We should, yeah, there we go, sweet. So right now, I'm getting every piece of data that is coming from that camera right to my machine right here. And I can then decide to do something with it. I could dump it into a database for analysis later. I can do some kind of processing. I can build out a dashboard with it. So that is another way we can kind of play that out. And there's a really good tutorial on create.meraki.io that allows you to kick this off pretty quickly. So I'll admit to you guys, I had not set up that MQTT broker up until last night, and I just wanted to make sure that it was going to work properly. And I got it going in about 5 minutes. So that part's pretty easy. If you just search MQTT on create.meraki.io, should be able to get that information relatively. Yeah, the camera intelligence APIs. So check that out if you want to start getting your hands on these kinds of things. Finally, and we are actually moving pretty quickly, so that's good. Finally, what I want to show you is the actual Meraki Beats demo. We have this all containerized within a Docker file, so that's how I'm going to launch it. You can get all of the code at github.com/Cisco DevNet/Meraki Beat. I'm going to jump back to my network here. So the reason I had to be on that network that I managed was because the camera was literally sending that data directly to my laptop, and I had to be on the same IP address space. So if you're wondering why I keep having to jump wireless networks, that's why. So this is all the code. It is a Go-based application, so I know that we talk a lot about Python in the DevNet zone, but the way that the Beats infrastructure is set up, and I think it was a little bit of a personal decision by the team, it's a Go application. So if you're not familiar with Go, we do have a workshop, I believe, that does some introduction to Go, so you feel free to check that out. The thing that I wanted to point out is that there are a couple of different ways you can deploy this. You can deploy and build the code from the raw code infrastructure, or you can we've Dockerized all of it, so it's all ready to go in Docker Compose. And that's how I'm going to kick it up. So it takes a little bit of time to start, and I wanted to have it up and running before I got here, but I didn't have a chance. So I apologize for that. But what we're going to do is I'll start it. We'll take a look at some of the code bits that are actually calling the APIs, and then once it's up and running, we'll take a look at some of the result set coming back from that. All right. So let's see here. Make this a little bit bigger. And are there any questions while we kind of wait for this all to? And hopefully this all works. It's all configured, or it was all configured properly. So we'll see if it starts running. Are there any questions while we? Yes, yeah.
I have a question. Can I send the streaming to another application, or only the data coming from the camera?
I didn't quite get it.
Can I send the streaming from the camera to another application?
Yes.
Only just like a.
Is it just what?
Few data, like.
Is it
like the counter or some other data?
So through the REST APIs, you can send them to any application. Through the MQTT publication, if what we just did now, as long as the camera can get to that actual application or that actual service, yeah, you can do that.
And the streaming, you can get it only from the Meraki platform, right? You cannot get it like through an IP address locally, or like through another, like HTTPS, or like.
Not the streaming information from the cameras?
Yes.
No, that doesn't exist now. Okay. I don't know. I have no idea if it's ever going to come, but as of right now, that you cannot do that.
Thank you so much.
Yeah, thank you for the question. Any other questions? No? Okay. It looks like we have our things running up properly, so that's good. The main thing that I wanted to point out for the location API, we do have to do a little bit of configuration. I'm going to close this. So our thing's up and running. I need to expose my laptop as a web server. So I'm going to do that with this tool called ngrok. And you probably, if you've been to any DevNet session before, you probably have heard of it. So now I have a public IP address, because what I need to do is configure my Meraki instance to talk to my location server. So There are a couple of different things going on. We talked about the cameras. We talked about the wireless health APIs, which are REST. We also have the location services bit. So if we go under network-wide general, I can then start to configure the listener service for my location and scanning analytics. So I'm going to put my ngrok IP or URL in there because I've exposed my laptop as a web server, and then it's pointing to endpoint API v1 scanning receiver, and that is the part of the Meraki Beats service that is accepting the Wi-Fi tracking data. Okay, so that's different from what the camera data is. So I'm gonna configure that. And ideally, if everything is working properly, I should be able to validate that they can talk to each other. All right, we might not have it up yet. That should be up. All right, we're just... Sorry, I'm going to change networks again. So bear with me. I'm going to push this all the way over. I have a feeling the Cisco Live Network is blocking these kinds of pushes. Yeah, that's what's going on. So now the location scanning receiver should be configuring and tying to it. While we're waiting for that to happen, I want to show you guys the code. So ignore that, ignore that, ignore that. Let's add project. The main part that I want you guys to take a look at is the different client spaces. So we talked about those health APIs, and let me make this a little bit bigger. And we can see within our code here, we start to, well, the first thing is we set our Cisco Meraki API key. And I didn't mention that when we actually looked at our Postman, but the Cisco Meraki API key is the validation that you are you and you are able to make API calls against that Meraki organization. So that's how it determines which org you're going against, which network you're going against, is that Cisco Meraki API key. So we're setting that in the header and sending that along. I've configured that as part of my launch of this file, so that mc.key was defined in some configuration file that is currently hidden. So it's coming in from that Meraki client package. The other thing that we're doing is making our API call to specific endpoints. And the other one that we want to look at is we need to get networks, so our API v0 organizations networks. So we'll see, we're only looking at one network in this particular instance, but if we had multiple networks, we would see more than one show up. So we'll be calling that. We see the implementation of the API in the code there. And we also see our network health API. So now that we've got our network list, we have networks, network ID, plus the connection stats for that particular network. And same thing for the latency stats. We see that here. So we actually see our API calls in code. Now we're implementing this stuff in something that is software-based and not just calling them from a Postman collection. Let's see if we are able to validate. We might be out of luck. It's just how far. Oh, we did validate. Yes. Okay. So we're validated. So that means my Beats instance can be talked to by Meraki. Now, if that connection persists, we may or may not be successful. And hopefully we have everything up and running, and I can kick over to Kibana. What was that? 5. So I apologize. I forget what the actual endpoint was. The nice thing is that this is all documented, and I can go check that out. $56.01, that's what it is. Ah. There we go. So I have Kibana running locally. I have the Meraki Beat service running locally. I could push this out to a containers cloud service, and maybe that would have been a smarter move today. But I have it up and running, and now I need to do a little bit of configuration. But the thing that I wanted to point out is that we have a bunch of now fields we can start to visualize and build those dashboards out with. I'm going to actually expand this so you guys can see all that data coming in. We have voice traffic, latency, best effort traffic, background traffic. These are all part of those reports coming out of the wireless health APIs. For the location services, we have client IPv6, client MAC, client latitude, longitude. This particular network doesn't have XY, so we're not getting that pulled out, but we can also see the client SSID. So all those are two of our data sets that we're working from. I did not get the camera API working properly, so I don't think we'll actually see the camera APIs in this. No, we do not see them in the list, so I apologize for that. But if we go to Discover, we should start to see data coming in now, and specifically, the one that I want to point out is the different types. So we had Meraki scan events, so that's a location scanning. And if you're familiar with that information, let me make it so that this is visible. We have our AP MAC address, or the MAC address of the AP that's making that report, that client MAC location, the receive signal strength with RSSI. Since it's not connected, we don't have any IPv6 or SSID information, but we do see that it's scanning probing clients, and we see a lot of those. And I just kicked this up, and it's coming in pretty quickly. And if I reload this, we should see even more reports coming through. Yeah, we're seeing 76 clients walk by at that time. It's also seeing 55 more after that. And so let me import a dashboard for you guys so you guys can see what that would look like. 1 second, let me make sure that I have, script fields, okay. And then we'll open it up for questions if there are any, because we have a little extra time, because I apparently spoke really fast. So we deployed a dashboard as part of this. Since I didn't open up the point of sale stuff, that's not going to show up, and we haven't gotten any latency in traffic because we don't have any devices connected. But we should have some network information. Maybe it's taken a second to get that queued up. If we look at Discover, we can hide the type that we want, and we can see if there's any information around them. That is not what I wanted to happen. Yeah, we've only got Meraki location scanning events, so we actually haven't gotten and they're happening fast. We haven't actually gotten any report on the latency. So had I actually started up at the beginning of the talk, which I should have done, and I apologize for that, we would start to see multiple types of information. We'd have the Meraki scan event, and we'd have the wireless health stats going in. But I hope we at least got the point across that we have these tool sets that are available to us to mash all these things together and generate dashboards that allow us to have some visibility at even a granular level. You can go for as high a level as you want, but even a granular level to help make decisions, keep some visibility in your networks, do that network monitoring that I talked about earlier. So I think we have about 5 more minutes. Are there any questions or concerns or wondering where you get things? How do I learn how to do this stuff? Any of that? No? All right. Well, I appreciate you guys hanging out and sticking with me through it. They are demoing this over at the demo pod, I believe, or at least we were yesterday. So if you want to have a little more conversation with someone about the implementation or what I just talked about, feel free to do that. I only have about 5 minutes. I got to go to yet another session, so I apologize for that. But I can chat. I can probably field a few questions afterwards if you want. But anyways, thank you for your time. Check out the Start Now zone if you haven't figured out or want to learn more about REST APIs, intro to Python, all that fun stuff, we have mentor sessions set up. So if you want to talk to someone about your Meraki journey and figuring out how do I do these integrations, we have people over there doing that. And this particular service is available in our code exchange. So if you go to developer.cisco.com and click on code exchange, you'll see all kinds of sample code, libraries, tools, all kinds of fun stuff tied to not just Meraki, but all of the technologies that we support within DevNet. So thank you guys very much for your time. I'll release you to the world.